So how do we know when to use linreg or quadreg in our calculator? Basically, we want to know when looking at a table of values, how do I know whether the information here is representing a quadratic function, involving x squared, would it give me the shape of a parabola, or is the information a linear function, giving the shape of a line? So one of the best ways to decide between quadratic and linear is to look at the differences. So when I say differences, we want our x value, our independent variable, to all be going up or down by the same number. Notice here they're all going up by 1. As long as that's happening, then you're good to go, and we're going to focus only on our y values, our dependent variables. So we're noticing the difference between each of our y values. So from 13 to 4, I subtracted 9. From 4 to 1, I subtracted 3. From 1 to 4, I added 3, so notice now it's a positive. From 4 to 13, I added 9. Then the second differences are the differences between those numbers. So from negative 9 to negative 3, I added 6. Negative 3 to 3, added 6. 3 to 9, added 6. Notice these second differences are all the same. If your second differences are all equal, you have a quadratic relationship. Over here, we knew we had a linear relationship because notice all the first differences were equal. There's this constant change. So if I want to look at a table and decide whether I should be using linreg or quadreg, I need to know, is it linear or quadratic? So notice my x's all go up by 1, so I'm going to focus on my y's. From 6 to 12, I added 6. From 12 to 22, I added 10. From 22 to 36, I added 14. 36 to 54, I added 18. 54 to 76, I added 22. 76 to 102, I added 26. So since I was adding that whole time, these are all positive numbers. There is none of these that are the same. Basically, we can notice that we don't have a constant difference. So I'm going to look at my second differences. Here I'm adding 4. 10 to 14, adding 4, 14 to 18, adding 4, 18 to 22, and 22 to 26. This now is a common second difference, which means this is a quadratic relationship. So if I wanted the equation for this data, I would type my x's in L1, my y's in L2, and use quadreg in order to get a quadratic equation. You try the next one. When done correctly, you'll notice that neither the first differences nor the second differences have a common difference, which means this is neither linear nor quadratic. Okay, why don't we try one more? This time, notice my second differences are all the same. So that means this is a quadratic function, and if I wanted the equation for this data, I would use quadreg in my calculator.